The Huanggang Road Tunnel, built in Jinan, China, is a monumental engineering marvel that runs beneath the Yellow River. This approximately 5.7-kilometer tunnel will connect northern and southern Jinan, completely transforming the city's transportation system. The massive tunnel boring machine, known as the Shanhei, is 17.5 meters in diameter and weighs 5,200 tons, and it drills its way through the soft soil beneath the riverbed inch by inch. A special pressure-balanced TBM system was used throughout the excavation to overcome significant risks, including water pressure, the risk of leaks, and ground subsidence. The 3-kilometer sub-river section was completed in just 110 days, a world record. Interior lining, ventilation, electrical, and safety systems are currently being installed. When the tunnel is complete, drivers will pass directly beneath the massive Yellow River, unknowingly passing beneath this massive structure. The installation of a giant crane is a complex process that combines planning, precision engineering, and heavy equipment coordination. First, hundreds of tons of steel components are transported to the crane site. These components include base plates, tower segments, boom arms, and counterweights. Once the ground is reinforced, assembly of the main tower mast section begins. Each tower segment is lifted onto the other using massive hydraulic cranes and secured with special bolts. After the electrical wiring, hydraulic systems, and control cabinets are installed, all systems are tested. Advanced sensors, camera systems, and joystick controls are installed in the operator's cab. A mesh welding plant or steel mesh production facility is a facility where steel mesh used in construction is automatically produced. Here, steel bars are first cut to specific lengths and fed into the machine. The wires, placed side by side and on top of each other, are then joined by a welding machine at the precise intersections using high heat. This process results in square or rectangular, highly durable steel mesh. The production line is generally fully automated. The machines perform the wire feeding, welding, and cutting operations sequentially. In the final stage, the produced mesh is cooled, stacked, and packaged for shipment to construction sites. Automation in reinforcement production refers to the use of advanced machines, robotics, and digital control systems to manufacture steel reinforcement with high precision and efficiency. In a modern automated reinforcement plant, raw steel bars are fed into cutting and bending machines that are fully computer controlled. These machines automatically measure, cut, bend, and shape the bars according to digital design data. Welding robots can then assemble rebar cages or mesh panels by joining the bars at precise points with consistent weld quality. Conveyor systems and automatic stackers move and organize finished products without manual handling. An adjustable staircase ramp is a smart hybrid system designed to function both as a staircase and an inclined ramp depending on the need. It's often used in modern buildings, warehouses, hospitals, or transport facilities where accessibility and flexibility are important. Zero slump concrete is a very stiff and dry type of concrete mix that shows almost no slump deformation when tested in the standard slump cone test, meaning it keeps its shape instead of spreading or collapsing. This happens because it contains very little water compared to normal concrete mixes.
In the heart of a mountain, giant drills are breaking apart rock masses, revealing tons of crystalline salt with a dazzling pink glow. Here is one of the most impressive underground treasures in the world, the Himalayan Pink Salt Mine. These giant machines, operating in the Kura Salt Mine in Pakistan, are constantly digging up thousands of tons of salt daily. In tunnels extending hundreds of meters below the surface, high-powered crushers break up the salt veins and transport them to the surface on special conveyor belts. Then, large rock blocks are turned into millimeter crystals with giant conveyor systems and hammer mills. The actual process in blue sapphire mining begins after the extraction of the mineral soil. This extracted mixture is first washed with high-pressure water, and then large pieces are separated with the help of vibrating screens. After this stage, the material is taken to special washing tanks that separate the sapphires using density differences. Here, the heavy sapphire stones sink to the bottom, while the light waste is removed from the surface. The stones obtained are manually checked and sorted by expert workers, and only those with a certain size and color pass to the next stage. Finally, these raw sapphires are shaped in precision cutting machines and made ready for use by adding shine. The salt mining process begins with special drilling machines to reach the huge salt deposits beneath the surface. Salt blocks extracted by blasting or mechanical excavation methods are collected from underground galleries by giant loaders and transported to the surface by conveyor systems. The salt that reaches the surface is crushed and ground in crushing machines, and then passed through screening systems to be separated according to grain size. In the final stage, the dried and purified salt is processed in packaging lines to reach the table. Aluminum mining begins with the extraction of the ore called bauxite from layers close to the surface, and the open pit mining method is usually used. Large excavators and loaders scrape off the bauxite layers and load them onto trucks, and this raw material is sent to refineries for processing. In the refinery stage, bauxite is crushed and processed with caustic soda at high temperatures to form a white powder called alumina. The alumina obtained is converted into pure aluminum by electrolysis, making it ready for industrial use. Phosphate mining is usually done by open pit method, and first the upper layers of the soil are scraped with large dozers to reach the phosphate-bearing layers. Then excavators dig these phosphate rocks, load them onto huge trucks, and carry them to crushing and screening plants for processing. Here the rocks are first broken down with crushers, then ground into fine pieces and separated from clay and other impurities in the washing unit. The pure phosphate obtained is sent to refineries to be used in the production of fertilizers and various chemical products. Zeolite mining begins with the identification of zeolite deposits near the surface using geological maps, and then excavating the soil using the open pit method. Large shovels and loaders extract zeolite-bearing rocks and load them onto trucks, which transport the raw material to crushing plants. Zeolite, which is broken into smaller pieces by crushing and grinding processes, is passed through screening systems and classified according to different grain sizes. Finally, the zeolite mineral, which is dehumidified in drying units, is packaged for various industrial and agricultural uses. Graphite mining is usually carried out by open pit or underground mining methods, and the process begins with the removal of graphite-containing rocks with large excavators. These rocks are ground into smaller pieces in crushing machines, and then subjected to a special separation process called flotation. In the flotation process, graphite particles are brought to the surface with water and chemical additives, while other minerals are precipitated and separated. The resulting graphite concentrate is prepared for use in high-tech areas such as batteries, steel, and lubricants after drying and purification processes. Kaolin mining begins with the identification of deposits containing white clay and is usually carried out by open pit methods. Large excavators and dozers carefully dig into the soft formations containing kaolin below the surface and load them onto trucks. This raw kaolin is transported to processing plants where it is mixed with water to form a slurry, then separated from sand, iron, and other impurities using hydrocyclones and centrifuges. The purified kaolin is packaged as a fine white powder for use in the ceramics, paper, and cosmetics industries after passing through drying systems. Limestone mining is usually carried out by open pit method, and the process starts with stripping the surface vegetation and soil layer. Then, explosives are placed in the rocks with drilling machines, and large limestone blocks are removed with controlled blasting. These blocks are transported to stone crushing plants with the help of excavators and huge trucks, where they are broken into smaller pieces using crushers. The ground limestone is classified and made ready for shipment for use in cement production, road construction, or construction industry. The diamond mining process is shaped by determining the area where the ore is located through geological analysis, and usually starting with open pit or underground mining methods. Kimberlite tubes carrying diamonds close to the surface are dug with large excavators, and the extracted rocks are transported to crushing plants. These rocks are broken into pieces in powerful crushing machines, and then separated by the density difference method. Diamonds are collected by sinking to the bottom in special separator systems because they are denser than other stones. In the final stage, these raw diamonds are selected by hand, classified, and sent to jewelry processing centers for the cutting process. Introducing the hydraulic metal press, the pinnacle of human power and engineering. This incredible machine harnesses tons of force with a single stroke and makes metal dance. This incredible machine can transform an ordinary sheet of metal into a flawless work of art in minutes. And the temperature? It can reach an incredible 30,000 degrees Celsius. A huge car, a giant plastic tank, or thick metal plates, they all shatter in a few seconds, introducing one of the most powerful demolition machines in the world, the Industrial Shredder. This giant machine not only destroys, but is also the indispensable hero of recycling. Here's an incredible technology that makes it possible: the rolling mill machine. A perfect combination of power and precision. This machine transforms steel, aluminum, and many other metals to create the fundamental building blocks of our modern world. Imagine a laser moving across a surface before your eyes, engraving intricate patterns with millimeter precision. Whether it's engraving a logo onto a smooth metal surface or transforming a sheet of glass into a work of art, this technology is awe-inspiring in terms of both speed and aesthetics. Imagine a robotic arm that collects, assembles, and transports complex parts with a margin of error of a few millimeters. Moreover, it does this without tiring, without making mistakes, and with a performance at the speed of light. It can perform many operations such as metal welding, assembly, painting, and even carrying heavy loads without any difficulty. Shaping the world's hardest metals, transforming steel into a work of art. Here is the tour de force that makes it possible: the forging press. This massive machine represents the pinnacle of engineering, displaying millions of tons of force in a single blow. A thin wire that moves like an invisible rope is charged with high voltage and sparks on the surface, separating the metal into atoms. And the temperature? It can reach up to 12,000 degrees Celsius. The molten metal poured into giant molds solidifies within minutes, forming the basic structure of the wheel. But this is only the beginning. Then giant milling machines come into play, shaping the surface with millimeter precision and ensuring perfect symmetry. Are you ready to watch the birth of a work of art? Meet the clay car model sculpting machine. This incredible technology behind the scenes of the automotive world shapes the cars of the future with millimeter precision. Imagine kilometers of thin copper wire being wound in perfect order in seconds. This machine calculates each turn with millimeter accuracy, creating the coils perfectly. Imagine thousands of products flowing rapidly through a factory line, but each one meets a perfect label in milliseconds. Here is the star behind this incredible process: labeling machine. This silent hero of the modern production world delivers an impressive performance by working with both speed and precision. These incredible machines are redefining the textile world and transforming production processes by working like artists. The fabrics are placed on the cutting table and the machine is activated. Lasers or high-speed knives perform each movement with incredible precision. Can you imagine what happens inside a giant drum when it rotates? With the combination of heat, motion, and a marvel of engineering, raw materials are instantly dried and ready for use. Here are the rotary drum dryers. One of the silent giants of industrial production, this machine operates with astonishing efficiency. Imagine products lined up perfectly on a fast-moving belt in a factory. Here is the hero behind this fascinating process: conveyor belt sorting machines. When speed, precision, and technology come together, these machines are the hidden masters of production. Giant rocks turn into tiny pieces of stone in a matter of seconds. Here is the power behind this incredible transformation. Stone crushing machine, an indispensable hero of the modern construction and mining world. This machine brings together pure power and technology. Imagine metal, plastic, or rubber, any material, passing through a thin opening, turns into a perfect profile. Here is the technology behind this magic extrusion machine. This machine, which forms the backbone of the modern production world, works like an artist who gives life to materials. Everything starts with the metal reaching thousands of degrees of heat and becoming liquid. Then, this liquid metal is poured into the machine's mold and solidifies rapidly. But what is truly fascinating is that this process never stops. The continuously flowing metal is shaped with millimetric precision and produces materials that are kilometers long. A hot plastic tube takes the shape of a bottle, a container, or a tank in seconds. Here is the hero behind this magical transformation: blow molding machine. This machine, the creative power of the modern production world, works with speed and precision to produce indispensable products of our daily lives. A tiny grain of powder turns into a perfect tablet in seconds. Here is the technology that makes this incredible transformation happen. Tablet press machines. Used in many areas from pharmaceutical production to the food and chemical sectors, these machines create a revolution in precision and speed.